Hey guys, welcome back. So in this video, I'm just going to cover the homework number 13, the mock exam homework. I'm just going to cover the few problems and let's get it. So let's go straight into it. I'll try to do another video for the um, multiple choice. So stay tuned for that, hopefully. Okay, so here we have the first question, pretty straightforward. So you have this monopoly, right? It says single cinema monopoly, and they are earning negative profits. So that's important information here. I like to highlight if possible. So why don't we go ahead and kind of highlight that negative economic profit. So let's start off with A. All right, and this is textbook. It's going to ask you to draw that graph. So we want to make sure that we're showing negative economic profit. And how do we do that? Well, let's draw the basics first, okay? So we're going to have price here, quantity on the x-axis. Then we're going to have a downward sloping demand curve, a marginal revenue curve that lies below it. And yeah, we'll do a marginal cost curve. So here's what you should do first. Identify where MR is equal to MC, which it's telling us in part AI as QM already, QM. Translate that point on the demand curve, and that's going to be PM. All right. So to figure out, we need to make sure that the average total cost curve lies above the demand curve for there to be negative economic profit. What do you mean? Well, first of all, let's draw the average total cost curve and show why. So if I translate our profit maximizing quantity up on the average total cost, clearly this point is above the market price. And so this is negative economic profit. So let's call this point, let's call it P2, right? And so if I'm getting a price, if I'm charging PM, but to produce QM, my average total cost is P2, which is greater than PM, I'm not making money, I'm losing money. So I'm going to shade this region in yellow to show that this is negative economic profits. Okay. This is negative economic profit. So this is negative profit. Cool. That satisfies AI and AII. So B, explain why single cinema continues to operate in the short run despite earning negative profits in the short run. So this question is simply asking you, well, it's not asking you, but you need to know where the average variable cost curve is. So because this firm is assumed to be producing in the short run, that means the price that it sells at the markets, PM, is greater than the average variable cost. So let me write that down. Explain. It produces in the short run because assumed, I don't know if I should write that like that, but it's assumed because price is greater or equal to the min average variable cost. What is this called again? This is called the shutdown criteria. So this is called the shutdown criteria. So what does that shutdown criteria say? It says that in the short run, a firm is going to produce in a short run as long as the price it sells its product is greater than its minimum average variable cost, or it's greater than its average variable cost. So that's B. Part C, let's do C. Let's be consistent here. I'm going to use blue again. So it's C. What would single cinema's total revenue increase, decrease, or stay the same if it decides to sell one fewer ticket? So, okay. So with total revenue is price times quantity. So if it decides to, give me 1 second here, if it decides to sell one fewer tickets, so if you look here, we can see that marginal revenue is increasing. Well, it's not increasing, it's actually decreasing, but it's positive. So in other words, if um, if this firm were to decide to sell one fewer ticket, then it's losing out on some revenue. So total revenue would decline. So I could write oops, why is it doing that? Oh, so give me a second. Hey, my marker, my pen just kind of decreased. Okay, that's part, what part is that? Part C. Part D, a single cinema hires in a perfectly competitive labor market. Sure, sounds good. Suppose the number of workers, suppose the number of workers available in the market decreases. What happens to the market wage rate? Explain. So, we're looking at the market here, and it's a perfectly competitive market. So, in other words, this question is saying that the supply of workers decreases. Well, if you refer back to our supply and demand model for the factor markets, for factors of production, specifically the labor market, the demand for labor would be the perspective of a business. The supply of labor would be the household supply of labor. We got wage on the y-axis and quantity of labor on the y-axis. So if there's less workers available, that would be a shift up of the supply curve. Okay. And as a result, we're going to get higher wages. If that's W2, dude, where's my marker not? W1, QL1 or QL2, this is QL1, okay? So what will happen to the workers? Let's do AI, wage will increase because supply decreases. Oops, decreases. Part two, what will happen to the marginal revenue product of the last worker? Sorry. So remember, each firm in a perfectly competitive market structure, in a factor market, sorry, is a wage taker. So what that means is the supply of labor for the individual firm is horizontal at the wage rate. So since the wage rate is higher, right, our supply curve for the individual firm rises. So what's going to happen is that the marginal revenue product of the last worker will increase. MRP, what's up, my marker man? Increase because MRP, because the wage rates is equal to the MFC, the marginal factor cost. So, to give you an illustration here, let's actually draw the individual demand curve for labor and the supply for labor for the individual firm. So we got wage, then we got MRP, then we got quantity of labor. So I'm doing what's called the individual firm's demand, which is equal to the marginal revenue product of labor. And so if the wage rate in the previous equilibrium is W1, this is also the marginal factor cost curve, right? And so if the wage rate rises due to supply decrease, then the marginal factor cost curve is higher, right? And so as a result, the MRP is higher. So there's actually multiple ways of saying it. You could say that there's an upward movement along the MRP curve as wages or MFC increases, which I've shown illustratively. So that's one. And I'm gonna move on to the second question. So give me 1 second while I get the second question. Okay, so I don't know if you can see it here, but am I shared screen? Yeah, I'm shared screen. Alrighty. So modern day word processing software gives consumers the ability to create and save documents in different file formats that can be accessed by multiple computer operating systems. The graph below depicts a perfectly competitive market for word processing software. In the graph, MSB is the marginal social benefit, MPB is the marginal private benefit, and MPC is the marginal private cost. MSC is the marginal social cost. All right, so let's work through that. Identify the type of market structure and explain. Well, it's gonna stretch out. Been sitting all day. This is a positive externality. Why? Well, let me write it down here to the right. This is a positive. Do my pen. My pen needs to work. Like, please work. Well, why? Because at E is the current equilibrium, and at E we can see that there is a positive externality at D, right? So positive externality because the marginal social benefit is, I'm going to use a thicker color, is greater than the marginal private benefit at 16 units. So in other words, there is some benefit to society at the consumption of 16 units. So it would be beneficial if there was more production of this good. It's pen, why? Just work. Oh, that's why. Okay, there you go. Using the numbers on the graph, identify the market equilibrium price. Well, that's going to be a price of $6 and a quantity of 16. C, using the labeling on the graph, identify the dead weight loss. Part B. So if this is the market equilibrium, if this at F is the socially optimal equilibrium, right, dead weight loss is going to be this triangle formed D, E, F. So I'm going to shade that in. Okay, that's the dead weight loss. So dead D, W, L. Part, let's say area D, E, F. Let's do D. You suppose the government is considering granting a subsidies to correct the market failure. What is the dollar value of the per unit subsidy that would achieve socially optimal quantity? Think of, if you're having a hard time thinking of an example, think of education. And so obviously education should be consumed more, right? It helps people get outside, get rid of poverty, and it's great. So what would the government do? I'm just going to erase this. It's going to subsidize the vertical distance between the marginal private benefit curve and the marginal social benefit curve. So that's this vertical distance. This would be the per unit subsidy. And how much is that? That's going to be 10 minus 6. So it's going to be 10 minus $6. That's going to be a $4 per unit subsidy. Okay. Okay. Now, part E, suppose the government does not grant the subsidy and instead poses a price floor, $8. So a price floor of $8. What's the price floor? Well, it's the minimum price that is charged in the market. That's the minimum price in the market. So it can't go below it. It can go above it, just like minimum wage. And so if what we can see here is that consumers, right, it's above the market equilibrium price of $8 or $6. So if we refer to the demand curve at a price of 8, only 8 people want to use it or who want to consume it. But suppliers, if we go to the marginal private cost curve, which is the supply curve, there is 24 units that are willing to be supplied in this market. So how many units will consumers and producers exchange at this price? Well, only 8 units. Only 8 units. Because that's what consumers want. They're not willing to pay anything higher. Price is too high. So that's part I. Now the question is asking, is the price floor correct for market failure? No. Because the marginal social benefit at 8 units being consumed is here at A, right? So clearly there should be more society benefits. There's some positive externality that's not being realized, and that there should be more consumption of this unit, such as education. So, and also, I'm going to be a little more simple here. At the social equilibrium, EQM, quantity is equal to 24. So therefore, since quantity since the price floor results in quantity less than 24, this does not correct. So again, the socially optimal equilibrium quantity is 24 units right here, and the price floor leads to a quantity of 8. So clearly, since 8 is less than 24, the price floor does not fix the market failure. Okay, part 2, Dunzo. All right, let's do the last question of the day, then we're going to head out of here. So we got here a textbook supply game theory question. So you have 2 firms, Air Touche and Windward. Air Touche and Windward both want to determine if they want to set up a new survey, a new schedule, either in the morning or evening. So the first question A is asking, which market structure is this in? It's clearly an oligopoly. There's 2 firms competing in one market because two firms competing in one market. B, if Windward decides to evening departure, which departure time is better for Air Touche? So evening, right? So and we're looking at these payoffs, 700 versus 900. Should Air Touche do morning or should it do evening? Well, clearly 900 is better than 700. And so Windward or Air Touche is going to evening because the payoff is greater. 900 is greater than 700. Part C, identify the dominant strategy for Windward. What is a dominant strategy? It is your decision, it's your move that you're going to do regardless of what the other player does. So let's see here. So we're trying to figure out if Windward has a dominant strategy. So let's say Air Touche decides to go morning. What's Windward going to do? Well, Windward's going to do morning as well, because evening only has a payoff of 600, and so morning has a better payoff, 700. If Air Touche does evening, what should Windward do? Windward also will continue to operate in the morning because 950 is greater than 800. So Windward is morning. Or D, is choosing an evening departure a dominant strategy for Air Touche? Well, let's figure it out. If Windward decides to do morning, what should Air Touche do? Well, it's going to decide to do morning. If Windward decides to do evening, Windward or Air Touche is going to do evening because 900 is better than 700. So no, Air Touche, no, does not have a dominant strategy because his or her move depends on what Windward does. E, if both firms know all of the information in the payout matrix but do not operate, what will Windward's daily profit be? So that's supposed to say cooperate. So we have to figure out the Nash equilibrium. So we know that Windward is always going to do morning, right? That's his dominant strategy. So what is Air Touche going to do? Well, it's going to do morning as well, because 7,000 is greater than 750. Hold on. So yeah. What is Windward's profit? $700. So I have to read. Oh. So that is pretty much it for game theory. I think I did an example in the previous video, but if you have any questions, please let me know via email or Google Classroom. I hope you guys enjoyed this, and I'll see you guys on Sunday.